All right, hello class. Welcome to this video on day one of the midterm review. Or part one, I'm going to cover one of the activities that we did for day one, starting with the maze for angle measures. Okay, so let's go ahead and start with this problem. So we got, first off, there are several angle pairs that you need to recognize throughout this activity. So in this case, if you look at these parallel lines, these two angles are on the inside and of this, what I call a sandwich. So I think of this as a bread, and then some kind of toothpick here. And so they're inside that sandwich, is what I call it. And they're also on the same side of the toothpick, or which we call the transversal. And therefore they're referred to as same side interior angles. Now, same side interior angles add up to 180 degrees. They're supplementary. So we're going to solve that by setting them equal to each other, or rather adding them and then setting that sum equal to 180 rather. All right, so then we can combine our like terms here. Subtract 24 on both sides. Divide by 13, and we get 12 for x. And so now you're going to want to plug 12 into the bold angle for x. So we got 9 times 12 plus 12, which is going to be 120 degrees. So that means we are traveling downwards. Now let's answer the next question. These two angles are known as alternate exterior angles because they're on the outside of the sandwich, and they're on opposite sides, on alternate sides of the transversal. And alternate exterior angles are congruent. And you can kind of tell this is an acute angle, this is also an acute angle. They look very similar, and so indeed they are congruent. So we're going to set them equal to each other. So we got 3x plus 17, 4x plus 6. Then I'm going to go ahead and subtract 3x on both sides just to move all the x's to the right-hand side. That's going to give me 1x. Then I'll subtract 6 on both sides, and so I get x is 11. And now I want to plug 11 into the bold here for x. So we got 4 times 11 plus 6. We get 44 plus 6, which is 50. So we're traveling yet again downwards down the maze. Okay, now these angles right here, notice that you have what looks like an X configuration where you have two lines crossing like that, a railroad, almost like a railroad crossing. Now you're on opposite sides. If you're on opposite sides of that crossing like that, then that means, so like directly across, and you can see, then those are referred to as vertical angles. Okay, so for example, if you have something like this, 1 and 2 are going to be vertical angles, or 1 and 2 are going to be vertical angles. But if they're next to each other, like 1 and 3, they're referred to as a linear pair. Okay, so that's different than, say, 1 and 2. All right, so for in this example, since they're vertical, they are equal to each other. So we're going to set them equal to each other here. So we got 20 plus 10x is equal to 11x plus 9. Go ahead and solve that. Let's move the x's to the right-hand side by getting rid of this one. This will be 1x plus 9 equals 20. And so x is equal to 11 because 20 minus 9 is 11. So then we'll go ahead and plug that into the bold angle here. 11 times 11 plus 9. That's going to give us 100, should be 130 degrees. This is going to be 121 plus 9. All right, so we're traveling diagonally. Now let's go ahead, and this is the one that I mentioned earlier. Right here we have this line and then this line. They're right next to each other. kind of like the example that I drew earlier, where you had a railroad crossing or whatever. 1 and 2 are vertical angles, but if they're next to each other, like these are next to each other, right, beside each other, then they're referred to as a linear pair. They add up to 180 because this angle and this angle leads to a half circle, and we know that a full circle is 360, and so a half circle is 180. All right, so that's one way of thinking about it. We'll go ahead and solve it. So we know it has to add to 180 because we got a half circle thing going on here. All right, so we got we'll do it over here. 11x minus 8 equals 8x minus 2. Go ahead and move the x's to the left-hand side this time, just because I don't want any negative numbers to deal with. So then now we'll get a positive 3x, bring down the minus 8, bring down the minus 2. Don't forget that's a negative 2. Add the 8 over. 8 minus 2 is 6, and this 3 times 2 is going to be 6. So x has to be 2. You can just divide 3 on both sides. All right, so x is 2. We're going to plug it in here to get the bold angle. So 8 times 2 minus 2 is, let's see here. Oops, I just told you that they add up to 180 and I ended up setting them equal to each other, so I apologize for that. I told you here that they're a linear pair, so they have to add up to 180, right? And I went ahead and set them equal to each other. Let me just go ahead and fix that real quick. All right. So these have to add up to 180. So we're not going to set them equal to each other. We're going to add them to 180. Let's go ahead and fix that. All right, so now they're adding up to 180. So now we can combine our like terms. Since they're on the same side of the equal sign, we can combine like terms right away. This is going to be 19x. This is going to be minus 10 equals 180. And then we'll go ahead and add 10 to both sides to get rid of it, get x by itself. So we got 19x equals 190. Divide off the 19 on both sides to get x completely by itself. X is 10. Now we plug that in. And so we get 8 times 10 minus 2 equals 78. All right, that sounds better. So it's going to be 78 degrees. So that means we're traveling up. So go to the next problem. So this angle, this is kind of like the one that we looked at earlier. Which one was that? It was, let's see here. No, we haven't seen that one yet, apparently. Okay. So these two angles, they're on the inside of the sandwich, but they're on opposite sides, right? So that means that these are alternate interior angles, and alternate interior angles are congruent. So you can kind of tell from this here that this is an acute angle. Look how tiny that angle is. It's an acute, and this is an acute. And so it kind of makes sense that they're congruent to each other. And indeed they are. They're congruent. So we're going to set them equal to each other. Okay, I'm going to get the x's on the right-hand side because I don't want any negative numbers. So I get 1x instead of negative x. And then we'll go ahead and add it to both sides. So x is equal to 8. And so now we want to plug in 8 into x here. So we got 6 plus 8 times 8. So 64 plus 6 is 72. So we got 72 degrees. Or rather, let me double check that. Oops, bad mental math. This is going to be 70 degrees. Okay, so we got 8 times 8 plus 6, so it's going to be 70 degrees. All right, so we have here going to the right. Okay, so now these angles, they're referred to as corresponding angles, and that's because they correspond to the same spot. So if you look at this is one angle, and I can just transfer that over and move it downwards, and it gets me the same angle. So they correspond to each other. And so that's what we call them, corresponding angles. And so clearly they're the same angle, and so they're congruent. Okay, so we're going to go ahead and set them equal to each other. And I want x's to be positive, so this time I'll move this over to the left-hand side. Get positive 1x plus 2 equals 7. And so we can clearly see x equals 5. 5 plus 2 is 7. So x is equal to 5. And then we'll go ahead and plug that into the bold. So we have 14 times 5 plus 2. Get 70 plus 2. And this one is 72 degrees. And now note that it doesn't matter if you plug it into x here or x here, because these two angles should be the same. So if this is 72 degrees, this should also be 72 degrees. But in cases where they're not congruent, then it does matter where you plug it in. Okay, so just be careful. So we got 72. We're going down. Now this one, remember, we have some kind of railroad crossing here. This is what I call it. Two lines crossing each other, and they're not on opposite sides like that. They're actually next to each other, right? So on the same line, basically. And if they're on the same line, then that means they're a linear pair. They're a pair that are on a line. Okay, so that means they add up to 180. Notice that they add up to that half circle. Okay, so 22x plus 2, and then 4 plus 7x has to add up to 180 for a linear pair. So these add up together. These add up together. We can subtract 6 on both sides. Divide by 29 on both sides to get rid of that 29. Let's see, 174 and 29. Let's see, 29 times 6. Is that going to give us our answer? Yes, it is. So it does go into it nicely. So it's going to be 29 times 6. Okay, so x is 6. So let's plug that in here. We get 22 times 6 plus 2. 22 times 6 should be, let's see, 132, and then 132 plus 2 is 134. Okay, so it's going to be 134 for the bold angle. So clearly we're going to be traveling in this direction. Let's continue. Now these angles, they're not any of the special angles that we looked at. Okay, so because this one's on top, this one's on the bottom, and they're both on the outside, and so we haven't come up with a name for this, right? I mean, they're exterior and they're on the same side, but there is no name for it that we've used. But we know that this and this angle right here, this angle that doesn't have anything on it, so this here and this angle, I'll do these in red, this angle and this angle, those are corresponding. And so you know that they have to be equal to each other. And so if that's x plus 86, then this is x plus 86. Now, if I look at this railroad crossing here, those two lines that cross, notice that if this is angle 1, this is angle 2, those 1 and 2 are vertical, but 1 and 3 are next to each other, right? Directly beside each other. And then therefore, they are a linear pair. They're part of the same line. They add up to 180. Notice that they add up to the half circle. So they're a linear pair. So these two angles are indeed supplementary. They add up to 180. So we'll go ahead and add the x's together. We'll combine the like terms. 106 plus 86, 192. We'll subtract 192 on both sides. And notice in this case, x is going to be negative because we get negative 12 out of this. And then divide by 2, we'll get negative 6 for x. So x is negative 6, but that's okay because we can plug it in to this bold and get an actual positive solution for an angle. So we got negative 6 plus 86. If we plug that in, and we get 80 degrees. All right, so now we're looking at alternate interior angles, or inside the sandwich, right? And they're on opposite sides of the toothpick, or the transversal in this case. All right, so that means that they have to be congruent. Notice that this is an obtuse angle, this is an obtuse angle, so they look the same. So they're congruent. We got 20x minus 5 equals 19x plus 1. Go ahead and subtract 19x on both sides. I want x to be positive, so this will be positive 1x minus 5 equals 1. And x has to be 6 because 6 minus 5 equals 1. Go ahead and show the algebra for that. So x is 6, plug that in to the bold. So we get 20 times 6 minus 5, and which is 115. All right, and this is actually the final problem in the maze. So this right here is the final step in the maze, and our solution is 115. So the answer to the final problem is 115. All right, guys, so that's going to do it for the video. I hope you found this useful. And as usual, see you in the next one.